All right, I think now I'm recording. Thank you for reminding me because, because of the break, I guess I just forgot. Thank you. Yes, so we said 2 weeks ago, we said like we have like two rules that we need to check whenever you want to find the domain, right? So we had like a first rule, we said we are not allowed to divide by 0, right? Rule 1. So we are not allowed, of course, to divide by 0. And rule number 2, we can't have negative numbers under the square root. Because we are only using, real numbers. We don't use complex numbers in this course. So we are not allowed to have negative numbers under the square root. Under the square root. Okay. So I don't remember how many examples I did in the last lecture, but anyway, so let me just again do more examples. So example 1. So let's say you have the following function. Let's say f of x is just a quotient. So let's say it's x over x minus 5. All right. So, and the question, of course, what I need to do here, I need to find the domain. Right. That's the question. So find the domain. So if you want to find the domain, guys, of a function f, there are only two things to check, as I said. So first, you need to check the first rule. Do we have a division here? Because the problem is we are not allowed to divide by 0. Okay, so you have to ask yourself, do we divide in this function f? And the answer, of course, in this example is yes, because as you can see here, this is a quotient, this is a fraction, right? So we do have a division, right? So we have to be careful here because we do have a division. So the denominator cannot be 0, right? So this is a division. So whenever you have a division, you need to solve denominator equal to 0, okay? And then you have to exclude the solutions from the domain of the function f, okay? And then, so that's like a first step. So this is like step 1. And in the second step, you have to exclude the solutions from the domain. Exclude the solutions from the domain. All right. Of course, here we don't have this a square root, so we don't have to worry about the rule number 2. Okay, so yeah. So let's do the first step. So step 1, just solve the denominator equal to 0. So step 1, I have to solve this x minus 5 equal to 0. So I can add plus 5 both sides. So then x would be equal to positive 5. So that's my solution, right? And as you can see, what's the problem with this value here with the 5? Well, as you can see, I mean, if my x right here is equal to 5, right, then as you can see in the bottom and the denominator, 5 minus 5 would be 0. So this whole thing here in the bottom would be 0, and that would be a problem, okay, because we are not allowed to divide by 0, okay? So that's the idea. So we have a problem with this. My input x, it cannot be equal to 5, right? X can be any real number except 5, right? So that's what I'm going to do in the second step. This is step number 2. So I'm going to exclude my the solution, which is 5 from the domain, right? So so this, my number line, it goes from, from negative infinity to positive infinity, right? And then somewhere I have 5. And what I'm saying is my x, my input x, it can be any real number except 5. So so it's going to be the whole number line except the 5. And so what we do to exclude the 5, we use parentheses. Okay, so the parentheses here means I'm excluding the 5 from the domain. Okay, so your answer, so the answer here to this problem, so my input x can be any area number except 5. So you have like, here you have like 2 intervals. First interval, it goes from negative infinity to 5, right? So it's from negative infinity, comma 5, okay? And as I said, we need to use the parentheses for 5 because we are excluding 5. Infinity, it's always excluded because infinity, it's not a real number, okay? So I'm going to use parentheses here with infinity, right? And then there's a second interval, and the second interval goes from 5 to positive infinity, 5 excluded, of course. So for the union, I'm going to use the capital U. So the capital U here means union. Okay. So union means I have 2 intervals. There's a first interval from negative infinity to positive 5, positive 5 excluded, and there is a second interval from positive 5 excluded to positive infinity. So my second interval, so it's from positive 5 to positive infinity. And of course, both of them are excluded. Okay. Again, the union, guys, means that I have like more than one interval. So here, what I'm saying is like I have 2 different intervals, right? So there are 2 different intervals. My domain is given by 2 different intervals. So we need to understand the domain here, guys. So what I'm saying is I can, my input x can be, for example, it can be equal to 5.01. That's not a problem. 5.01, it's fine because as you can see here in the denominator, if my x is 5.01, then 5.01 minus 5, that's 0.01, right? And that's not 0, so it's fine. Denominator is equal to 0.01, that's fine. That's not a problem, right? So in this domain, I'm excluding all. I'm only excluding 5, right? So you can have x equal to 5.01 or 5.001, or 5.00301, etc. So x can be, my input x can be any real number except the 5, all right? There's only a problem with the 5. Yes.
So the domain is whatever number that makes the denominator equal to 0.
No, the domain is whatever number which makes the denominator not 0. Right?
Okay.
So here, right, that's what I'm saying. So my domain is any number except the 5. So which means that my denominator, it's any near number for which the denominator is not 0. Mm-hmm. All right. Any other question, guys? But just keep in mind, so whenever you have this domain, this is probably going to be like in the second problem in your test. You want to find the domain of function f, you have to ask yourself 2 questions. Is there division or is there a square root? So as you can see here, whenever you have a division, you have 2 steps, right? You have to solve the denominator equal to 0, and then you have to exclude the solutions. Bajan, you're saying you don't get what's the problem exactly, Bajan? what's the, how you got 5? Yes. Well, as you can see here in the first step, I solved the denominator equal to 0, because that's where I'm gonna have trouble if my denominator is 0. So that's how I got the 5. I solved my denominator. As you can see, my denominator is x minus 5, right? And when I solved x minus 5 equal to 0, then my x is equal to 5. That's how I got the 5. And as I said, as you can see, if my x here is 5, then denominator would be 5 minus 5, which is of course 0, and we're not allowed to have 0. So that's how I got the 5. Does this answer your question, Bajan? How I got the 5? Okay, perfect. And so once you got the 5, and because you know you're gonna have a problem with the 5, if your input x is 5, you're gonna have a problem. The problem is the denominator is gonna be 0, right? So then in the second step, you have to exclude the solutions you got from the first step, right? So here, when I said exclude the solutions, that's the solutions from step 1. Okay. All right. Any other question, guys? Okay, so that's first example. That's when you have a division, right? So now let's move to second example. In the second example, we're gonna have like a square root, okay? So, and that's a different problem. So example number 2. So let's say my f of x is square root of x plus t minus 2. Okay? And as you can see, the minus 2 is outside the square root, okay? So, and of course, the question again, so what we need to do here, we need to find the domain. And again, the domain that's the set of all x values that you can input, right? So let's see what's the domain. Well, as I said, first, 2 things to do, right? Whenever I want to find the domain, first you need to check if there's a division, right? Obviously here there's no division. Okay, so there's no division. Okay, that's good. And then the second thing to check is if there is a square root. Okay, is there a square root? And the answer, of course, here is yes, there is a square root. Yes. Okay, so here's my square root, right? Here's my square root. Okay, now what's the problem with the square root? The problem is, as I said in the rule number 2, we cannot have negative numbers under the square root. So whenever I have the square root, guys, and you want to find the domain, you're going to have, again, 2 steps. So in step number 1, you need to, so in the first step, you need to make sure that what's under the square root is positive or 0, right? Because it cannot be negative. Okay, so we need to make sure that, you know, what's under the square root. So under the square root here, we have x plus t. As you can see, the minus 2, it's outside the square root, so we don't really worry about the minus 2, right? This is outside the square root, so we don't really care about the minus 2, all right? Now, what's under the square root? It's x plus t. That's what I have under the square root. So under the square root, it's x plus t, right? And I need to make sure that this x plus t is positive or 0, right? Because if my x plus t for some reason is negative, then it's just undefined, because we cannot have negative numbers in the square root. So for example, if my x is negative 6, so if my x is negative 6, as you can see, negative 6 plus t would be negative 3, right? And I'm not allowed to have negative 3 under the square root. So my input x cannot be equal to negative 6. All right, so we need to make sure that this x plus t it's not negative. So we need to make sure that this x plus t, it's positive or 0. So let me just write it in words. So we need to make sure that x plus c is positive or 0. Okay. Now, how do you make sure that x plus c is positive or 0? So we need to solve some inequality, right? So x plus c positive or 0 means it's larger or equal to 0. Okay. So this is simple here, guys. This one here means it's larger or equal. Okay. So the equal or equal, because we have this, you have this line here. That's why we have larger or equal, right? So just to remind you, probably, so if you have like something like this here, this means this is strictly larger than 0 or strictly larger. Okay. Now, if you have like a line, like this, something like this, right? This is larger or equal. So this is or equal. Okay. So in our case, we need to make sure that x plus c is positive or 0. So it can be equal to 0. Okay, because if x plus c is 0, square root of 0 it's equal to 0. That's well defined because 0 times 0 is 0, right? So we need to solve this inequality, right? So we need to find the set of the values of x for which x plus c is positive or 0, or larger or equal to 0, okay? Again, so larger or equal to 0 means it's positive or 0, right? Now, so let's solve this inequality, right? So, well, I need to solve for x, of course. So what we can do, we can subtract. So probably I'm gonna erase this thing here. So we can subtract 3 from both sides. So here's like minus 3 from both sides. I mean, this works like an equation, right? So you subtract the 3 and then you get x on the left, and on the right, it's 0 minus 3. So that's negative 3. Okay. So if you want your x plus 3 to be positive or 0, then your x, so what we are saying here is that my x needs to be larger or equal to negative 3, right? So that's how we read this inequality here. So this means that x is larger or equal to negative 3. Okay. So if my x is larger or equal to negative 3, then x plus c is positive or 0. Okay, so then x plus c is going to be positive or 0. Okay, so that's the first step. So again, so the first step, all you have to do, guys, is you have to solve what's under the square root larger or equal to 0, right? So that's what I did here. Under the square root, I had this x plus c, right? So I took the x plus c, that's what I had under the square root, and I solved the inequality larger or equal to 0, okay? X plus c larger or equal to 0. That's always like the first step. Whenever I have a square root and we want to find the domain, that's what you do in the first step. Now, in the second step, and in the second step, this is like for the division. So I'm gonna try to find the domain, of course. So I'm gonna use my number line. Here's my number line. You know, as usual, you have negative infinity, you have positive infinity, right? And let's say somewhere you have your negative 3. Right? Now, from the first step, so what we are saying in the first step, so we are saying that the input x is larger or equal to negative 3, right? That's what we are saying here in the first step. So my x is larger or equal to negative phi. So that will be on the right side of negative phi, right? If you are larger than negative phi, so you're supposed to be on the right side of negative phi, okay, on your number line. So this is larger or equal, so to negative phi. So x, your input x can be equal to negative phi. So we need to include the negative phi, right, in the answer. So I'm going to include the negative phi, and the way to include numbers is to use a bracket. So I'm going to use a bracket at negative phi. So that means that negative phi is included. It's included because my x, can be equal to negative phi, because the input x, because x can be equal to negative phi. Okay, so we use brackets to include the numbers, okay? So this is my bracket here. Right, so the bracket means it's included. So that's different from parentheses, right? Parentheses means it's excluded. Bracket means it's included. Okay, so in the final answer, guys, in your final answer domain of this function f, as you can see on this number line, we have only one interval. So this is different from the previous example, right? So there's only one interval. As you can see, this one here, there's one interval, and the interval goes from negative phi to positive infinity. So that's like negative phi, comma, positive infinity. Okay, and as usual, infinity is excluded. So that's the parentheses here. But now the negative phi is included, so we need to use a bracket. So I'm going to use a bracket here for negative phi. So then again, bracket means it's included. This is excluded. All right. So the answer here, so what we are saying, guys, is that my input x can be any number, larger or equal to negative phi. So it could be, for example, negative 2. So negative 2, for example, it's larger than negative phi, right? And as you can see, if my x is negative 2, well, here, under the square root, so my x is a negative 2, then that would be negative 2 plus 3. That would be positive 1. So that would be square root of positive 1, which is, of course, positive 1, right? So my input x can be negative 2. So all I'm saying here in this answer is that my input x can be any number on this side of the number line, on the right side of negative phi. And now if you pick a number which is on the right side of negative phi, so for example, a number less than negative phi, so for example, negative 10, right? Then you can see you'd have a problem with the function f, because if your x now is negative 10, it's negative 10, then negative 10 plus 3, that will be negative 7. So we're going to have a square root of negative 7, and that's undefined, right? So that's not allowed, okay? Any question, guys? I can probably check the chat. Yeah, okay, there are no questions in the chat. Yeah, so all you have to keep in mind, guys, whenever we need to find the domain of a function, again, you have to ask yourselves just 2 questions, all right? Is there a square root? Sorry. Is there first a division? So if there is a division, then there are 2 steps. You have to solve denominator equal to 0, and then you exclude the solutions from the domain, right? Now, there's a second case, a second problem, which is the square root. So if there is a square root, okay, then what you need to do is, in the first step, it's not like solving the denominator equal to 0. When you have a square root, you have to solve what's under the square root, right? Larger or equal to 0. Okay, so that's different from division. Division, just solve denominator equal to 0. Square root, you solve what's under the square root, larger or equal to 0. Okay, so yeah, just that's what you have to keep in mind. Okay. Let's do an exercise, guys. All right. So here's an exercise. Exercise. All right. So the question, of course, it's to find the domain. So you need your answer to be, of course, find the answer, guys. It has to be in interval notation, right? Using this bracket, parentheses, etc. So please try to find the domain of the following functions. Let's say 1, 2, 3. Okay, let's have 3 functions. All right, first function, f of x. Let's go with something very simple, which is just x squared minus x, right? Second function, f of x, is, let's say, x minus 4 over 2 minus x. 3, f of x is equal to, let's see, square root of, let's see here. Yeah, let's go with the square root of 2 minus x plus x squared, right?
Professor, can I please see how you got step 1 of example 2, please?
Example 2. Yeah, sure. Here, right here. So step 1, you have to solve, what's under the square root larger or equal to 0, right here.
Thank you, I got it.
Sure. So again, let me just write it down here. So division, so if you have a division, you have to solve denominator equal to 0, and then you exclude the solutions from the domain. If you have a square root, so you have to solve what's under the square root, larger or equal to 0. Okay, and that will be your domain. So after this, guys, we'll see how to find the domain using graphs, right? If the function is expressed or described by graph, so we'll see how to find the domain in that case. I think I'm gonna need. I'm gonna add another problem, another function. So number 4 is gonna be kind of tricky, but so in this number 4, we're gonna have at the same time a square root and a division, all right? So that's why I'm gonna do this example. So let's say here you have 2 minus x over square root of 4 plus x, and then let's say minus 2. I mean, because you know your function f can be kind of a little bit complicated, right? So sometimes you get like in this example number, this problem number 4, this function f, you're gonna have like both division and a square root. So I guess number 4, it's a little bit tricky, but just try to follow the steps, guys, right? All right. Do you need more time, guys? Anyone needs more time? Well, at least to think about the first 3 functions. If you have a trouble with number 4, I mean, that's fine, because I think that's like the first example where we have like both division and square root. So, but I mean, I hope you got the answer for number 1, 2, and 3. Okay. All right. So yeah. So let's do this. Let's start with number 1, of course. So that's f of x equal to x squared minus x, right? And of course, the question is to find the domain. Right? So as I said, there's 2 questions here. Is there a division? Right? That's the first question. Is there a division? Right? So obviously here in this first, the first function f, x squared minus x, there's no division, right? So the answer is no. Okay, good. That's a good news. Now, second question, of course, is there a square root? Square root. And the answer is no, right? There's a power, there's a square. It's not square root, right? So no. So which means that actually there's nothing to do here, right? There's no division. So I don't have to solve like denominator equal to 0. There's no square root. So I don't have like to solve some inequality, right? So there's nothing to do here, which means that my input x can be any real number. There's no problem here. X can be any real number, right? So the conclusion is that, so nothing to solve. My x can be any real number. So like this is my, let's say this is again my number line. It's negative infinity, positive infinity. And what I'm saying is my x, my input x can be any real number. Right? So the answer will be the whole number line, right? So if I answer domain of this function f, it's the whole number line. So you start from negative infinity as usual, and you can go all the way to positive infinity, right? Does this make sense to you guys? Any question about this? So all I'm saying is the value of x here, my x can be any real number. There's no problem. There's nothing to exclude here. Okay, x can be 0, can be 1, it can be anything. All right, no questions? Okay, so now for number 2. So for number 2, my f of x is, let's see, where's number 2? So it's x minus 4 over 2 minus x. So it's x minus 4 over 2 minus x. All right, and as usual, you find the domain. So first question is there a division? And the answer is yes, right? So if there's a division, well, then you need to follow the two steps that we have. So in the first step, and let me answer the other question, right? Is there a square root? And the answer, of course, is no. Okay, so because we have a division, right? So then in the first step, I need to solve a denominator equal to 0, the whole denominator, of course. Denominator equal to 0. So that'll be the 2 minus x equal to 0. And so for x, of course, the easiest way here to solve for x is just to add plus x both sides, so plus x. So plus x would be the opposite to minus x, right? So then this minus x plus x cancel out. So it's just 2 on the left and just x on the right side. Okay, so I got my solution here, x equal to 2, right? So what does it mean x equal to 2? Well, it means that if x is 2, as you can see here, if this x is 2, then the denominator is going to be 0, right? 2 minus 2, that'll be 0. And we are not allowed to have 0 in the denominator, right? So so there's a problem with the number 2, right? Because so we have to exclude. So in the step number 2, we have to exclude the solutions from the domain. Step number 2. So we have to exclude the solutions from the domain, right? So here's my number line. As usual, there's 2 here somewhere. All right. And what I'm saying is just, I need to exclude this number 2. So my domain, my input x can be any number except this positive 2. All right. So your final answer should be like, so you start from the left, you go from left to right. So negative infinity, and then you have to stop, comma, and then you have to stop at positive 2 because you have to exclude the positive 2, right? So we need to stop at positive 2. So the positive 2 here is excluded. Here's parentheses with an infinity, right? That's my first interval. And then the second interval, there's a second interval, and the second interval starts again at positive 2 excluded, right? So there's a second interval from positive 2, comma, positive infinity, right? So, and again, this positive 2 is excluded and infinity is always excluded, right? And then because, this number 2 is like separation between 2 intervals, right? It separates like the first interval, this one here, and there's this is a second interval right here, okay? So then that's why I'm gonna use union. Right. So again, it's because this number 2, it separates the 2 different intervals. The one on the left of positive 2 and the other, which is on the right side of positive 2. Okay. Any question, guys? But again, you need to see, guys, here, when I say that this is my domain, what I really mean is my number x, my input x, can be any near number except the positive 2. And again, it could be 2.1 or 2.01 or 2.001, anything like decimal or, close to 2 or except 2, except positive 2, okay? Any question, guys, about this number 2? All right, now let's do number 3. What's number 3? It's 2 minus x plus x squared. Okay, 2 minus x square root, of course, sorry. So f of x, it's square root of 2 minus x plus the x squared. All right, same questions, same thing. Is there a division? The answer is no. That's a good news. So if there's no division, so we don't have to solve like a denominator equal to 0 or anything. Now, the second question, of course, is there a square root? And then the answer is yes. So if the answer is yes to the square root, the answer is yes. So because there is a square root, then we need to, as a first step, so we need to solve what's under the square root larger or equal to 0, right? And again, only what's under the square root. We don't really care about what's outside the square root. So like here in this example, there's this x squared. We don't really worry about the x squared. It's outside the square root. Okay, so what's exactly under the square root is the 2 minus x, right? This is 2 minus x. And I need to make sure that this 2 minus x is positive or 0. Okay, because it's under the square root. So how do I make sure that this 2 minus x is positive or 0? Well, I need to solve 2 minus x larger or equal to 0. So larger or equal to 0. So this larger or equal to 0, guys, means it's positive or 0. That's what I mean by this larger or equal to 0. It's positive or 0. Okay. Okay, so I need to make sure that this 2 minus x positive or 0. So I need to solve this inequality, right? I need to solve for x as usual, right? So it's like an equation, right? So this inequality is just like an equation. So you have to solve like the same way, right? Just be careful with the sign. So for example here, well, of course, you can, for example, well, let's just subtract, for example, minus 2. I'm gonna subtract minus 2 from both sides. So if you subtract, this is plus 2. So you subtract 2, then the 2 cancel out, of course. So then on the left, you would have minus x, larger or equal to 0 minus 2, that's negative 2. Right? And again, I need to solve for x. Here, there's a problem. This is not exactly x, it's minus x, right? So we need to get rid of this minus. There's this minus here, as you can see, guys. So we need to get rid of the minus. And how do we get rid of the minus? Well, there are 2 different ways, actually, to get rid of the minus. Either you multiply by -1 or you divide by -1. So let's say you need to divide by -1, right? So I'm going to divide both sides, of course. Whatever you do on the left, you do the same, exactly the same on the right side. So I'm going to divide by -1. Okay. So as you can see, when you divide by negative, so negative over negative, that will be positive. Okay, that's the point here. That's why we are dividing by -1. So negative over negative, that will be positive. Okay. So then x would be, on the right side would be 2, right? Then here you need to be careful. The thing, guys, is, so if you have like an inequality and you divide or you multiply by a negative number, then you have to change the inequality. So then x now becomes actually less or equal. So this is less or equal. And so that's because, so I changed the inequality here, guys, because I divided by a negative number. So whenever you divide, if you divide or multiply by a negative number, or multiply, if you have an inequality and you divide or multiply by a negative number, you have to change, you need to change the inequality, right?
Professor, I got a question.
Yes, please.
What if you added x to both sides instead of?
You can do that too.
But then it will be 2 is greater than or equal to x.
Yes, absolutely right. And that's actually the same thing. So yeah, that's a very good point. So yeah, that's a good suggestion. Well, I did this. I subtracted 2 here just to show you that whenever like you divide or multiply by a negative number, then you have to change the inequality. But yes, another way to do it, as you're saying, you can just say, like you have 2 minus x, right? And so what you suggested was to add, I'm gonna add plus x, and then that would be 2 on the left, larger or equal to x, okay? And that's actually the same answer. So as you can see here, what we are saying is x is less or equal to 2, right? And here we are saying that 2 is larger or equal to x. That's the same thing, right? So like on my number line, so this is my number line, this is 2, negative, positive. So here we are saying that x is less or equal to 2. So that will be this side here, left side of 2. Or here we are saying that 2 is larger than x, and that's the same thing. So 2 is larger than x, it means that x is less than 2, right? So 2 larger than x, well, it means that x is less than 2. Okay, so that it's the same, you get the same answer, right? And yes, and actually x can be equal to 2, right? Here, because of this line here, your x can be equal to 2. So we need to include the positive 2. This is supposed to be my step number 2. All right, this is supposed to be my step number 2. So final answer would be, so the domain is negative infinity all the way to positive 2, and infinity is excluded, of course. Positive 2 is included, right? So we use a bracket for positive 2, so included. That's my domain. So what I'm saying here, really, guys, is that my x, my input x, it cannot be a number which is like larger than 2. For example, if your input x is 5, right? 5 is larger than 2. So if your input x is 5, you can see here in this function f, you would have a problem if your x, this x here is 5, right? Because you would have under the square root, you'd have 2 minus 5, that would be negative 3. So there'll be square root of negative 3. That's undefined. That's not, I mean, it's just undefined, okay? Because square root of negative 3, it's not a real number, okay? So that's all I'm saying. And of course, my x, my input x, can be a number which is less or equal to 2. So for example, it can be, for example, negative 1, okay? So as you know, negative 1 is less than 2, right? So, and you can check, so if your x is negative 1, right here, this x, of course, is negative 1. There'll be 2 minus negative 1. But then, 2 minus negative 1, that will be 2, because minus minus, it's a plus, that will be 2 plus 3. 2 plus 1, which is a positive 3. So that will be square root of positive 3. And that's well defined. That will be some number. Right? So, yeah, so that's what I'm saying here. Any question, guys? I know sometimes you can easily get confused with the, large or equal, less or equal. So again, this is, oops. So you have something like this. This will be larger, strictly larger, or larger or equal, with a line here. And the other way, this one here, that will be less or equal. Okay. Any question, guys? All right, no questions, that's good. So let's move to the number 4. As I said, number 4 is kind of tricky because we have both division and square root. So what's the number 4 again? I'm sorry, I need to find my number 4. Yeah, so it's 2 minus x over this square root of 4. So number 4. So my f of x is this 2 minus x over square root of 4 plus x minus 2. All right. And of course, question is to find the domain. I need to find the domain. So as usual, I'm gonna just follow the steps. Oops, that's not what I want. Yeah, right here. So is there a division? That's the first question. Is there a division? Right, and we need to see if there is a square root, right? Square. So the answer to the first question, is there a division? Yes, because as you can see, it's a fraction here. So yes. Is there a square root? And yeah, yes, the answer is yes, because of this square root right here, right? So, all right, so the answer to both questions is yes. That's not really good news, but let's see how it goes, all right? So first, from the first question, the division, yes. So we need to, as a step, let's call this step 1. We need to solve the denominator as usual. Solve the denominator equal to 0, right? That's always the first step. Whenever we have a division, that's what we do to find the domain. And as you can see, guys, I mean, we don't really care about the top, right? We don't really care about the numerator. It just, it doesn't really matter for the domain, okay? So yeah, so we need to solve the denominator. Let's see what's the denominator. So the denominator, of course, is the whole thing in the bottom, right? So the whole thing, that will be square root of 4 plus x minus 2. So here we need this minus 2 because it's in the denominator, right? So we need this minus 2, right? So that will be this thing here. That will be my whole denominator. So the minus 2, I need to include this minus 2. All right. So solve denominator equal to 0. So here's my equal to 0. All right. So let's try to solve this. You cannot really touch what's under the square root for the moment, guys, because of there's this minus 2. So first step, we need to get rid of this minus 2. So we're gonna just add this plus 2 both sides. So 2 cancel out. So now it's just square root of 4 plus x equal to positive 2. All right. Now I can get rid of the square root. And the way, of course, to get rid of the square root is to use a square, right? So I'm gonna apply square to both sides. So let me just write down again the same thing. So I'm gonna apply a square to both sides. So here's my square. Here's the square, both sides. All right. And as I said here, because I applied the square, then this square root cancel out. So now it's 4 plus x on the left, and on the right, it's 2 squared, which is of course 4. 2 times 2 will be 4. All right, and of course the goal is to solve for x. So I'm gonna just subtract 4 both sides. So that'll be x on the left, and 4 minus 4 on the right, that'll be 0. So the solution here is x equal to 0. Okay, and you remember, guys, once you solve denominator equal to 0, then you need to exclude the solutions in this next step. We need to exclude the solutions. Well, here we got just one solution, so we exclude the solution from the domain, right? We need to exclude this from the domain. That's what we do when we have a division. All right, I need to exclude this from the domain, but of course, as I said, we do have a square root, right? So we need to take care of this square root. So now, because we do have a square root, then we have to solve what's under the square root larger or equal to 0. So let me use here blue here. So because we have a square root, right? Then as a next step, the next step would be to step number 2. So we need to solve what's under the square root larger or equal to 0. Okay. And what's under the square root? Well, under the square root, it's just 4 plus x, right? That's what's under the square root. So this thing here, this 4 plus x, that's what's under the square root. So let's do this. So it's 4 plus x. That's what's under the square root, larger as usual, larger or equal to 0. Okay, so we need to solve for x. We can just probably subtract 4 from both sides. And if you subtract 4, then that will be x on the left, and then larger or equal to -4. Okay. So what I'm saying here is that my x can be any number larger or equal to -4, right? Now, in the last step, we need to combine the solutions we got in the first step and the second step. Now, in the first step, we said, well, I solved the denominator equal to 0, and I got this solution x equal to 0, and we need to exclude this x equal to 0 from the domain, right? And in this second step, when I solve this what's under the square root larger or equal to 0, I'm saying my x can be any number larger or equal to -4, right? So in this last step, I'm gonna try to combine like the first and the second step. So in this step number 3. All right, here's my number line, okay? Negative infinity, positive infinity. So what I said in the first step, so step 1, we got this x equal to 0, right? And we said this needs to be excluded. X equal to 0 needs to be excluded, right? So I'm gonna need probably 0 here somewhere. And in the step number 2, what I said is my x is larger or equal to -4. Okay. And that will be like in the domain of my function f. So here's my, I'm gonna just put the 0 here, and here's my -4. All right, so from the step number 2, what I'm saying is my x is larger or equal to -4. So that'll be like the right side of -4, but we have to exclude from the first step, we have to exclude the x equal to 0, right? So when you arrive at x equal to 0, we have to exclude it. So here's x equal to 0, excluded, right? And then you can continue your way to positive infinity, right? So from the second step, what I'm saying is my x should be on the right side of -4, larger or equal to -4. It can be equal to -4, so I can include the -4, okay? But from the first step, what I'm saying is I have to avoid or exclude the x equal to 0. So that's why I'm using parentheses at x equal to 0. So your final answer, guys, should be, so for this function f, final answer domain is, so how many intervals do we have here? Well, as you can see, the 0 would separate like the 2 intervals, like from -4 to 0, that would be my first interval. Like this one here, this is like my first interval. And then there's a second interval, like from 0 to positive infinity. So the answer here, domain, is gonna be like the union of 2 intervals. So first interval from -4, 0, that's my first interval. -4 is included because my x can be equal to -4, right? Can be equal here. And then 0 is excluded from the first step, right? That will be my first interval union. My second interval would be from 0, of course. You start again at 0, 0 excluded, and all the way to positive infinity. So positive infinity. excluded, of course. And again, guys, I mean, if you want to understand what we are doing here, you can just come back to your function f. So again, just to remind you, what's my function f? My function f was like, I think x minus 2 over square root of 4 plus x minus 2, all right? So what I'm saying here with this answer, what I'm really saying here is that my input x, my number x, can be any number in this interval. So it could be, for example, -3, right? It could be -3. And you can see here, if x is -3, there's no problem. Like in the top, -3 minus 2, that'll be -5. And in the denominator, that will be square root of 4 plus -3. That will be square root of +1 minus 2. So you can compute the answer here. Like that will be 1 minus 2. That will be like -5 over -1. And the answer is 5. So if your x, for example, is -3, then you can compute your f of x, the corresponding output y, right? There's no problem. You can pick a different number, for example, here, larger than 0. You can pick 5 or whatever, right? There's no problem. You can compute the corresponding output y. Now, if you pick a number which is not in your domain, so for example, you pick a number here, let's say -10. So if your x is -10, then you see you're gonna have a trouble. You're gonna have a problem. Like if your x is -10, then in the top, well, -10 minus 2, that's fine. That would be -12. But in the denominator, here, -10, 4 plus -10. This should be 4. 4 plus -10. And then this is -2. So in the top, that'll be -12. That's fine. But here in the square root, you're going to have like square root of 4 plus -10. That will be square root of -6 minus 2. And the problem is this square root of -6, it's undefined, right? Which means that there's no corresponding output y. And that's a problem. Okay. So what I'm saying with this answer, guys, is that my input x can be any number in this interval. And so you have to avoid all the real numbers outside this domain. Okay. Well, I hope it makes sense to you guys. Is there any question? I mean, please don't be shy. I mean, I'm here just to answer your questions. I mean, if there's something mysterious or, all right. No questions. Okay, good. All right. So then, so that's how we find the domain in general. Whenever I have an equation, that's how we find the domain. All right. Now, next, we're gonna again try to find the domain, but this time my function f is described by a graph. Okay, so I'm gonna show you how to find the domain when the function is described by a graph. Okay. Okay, so probably I'm gonna just erase this example here.
Professor, can I see step 1, please?
Step 1, sure. Step 1, right here. So for the graph, guys, I'm gonna show you I'm gonna explain how to find the domain with some examples. And probably I'm gonna give you an exercise after. Okay. Are you done with the step 1?
Yes.
Yeah. Okay. Perfect. Perfect. Thank you. All right. So yeah. Next. All right. So this is our question number 2 for today. Number 2. So how do we find the domain using graphs? All right, so I'm gonna show you with an example how to find the domain. So first example 1. example one. I'm going to give you a couple of examples because, you know, I don't know if you remember this, guys, but, you know, there are like, we can use like different notations in the graphs, you know, there's full circles, empty circles, arrows, etc. But let me start with like very simple, basic graph. Okay, so graph number one, as usual, this is the input x, the x-axis right here. This is 0, 1, 2, etc. -1, -2, and this is the y-axis. That's the output y, the y-axis, y, 1, 2, etc. And of course, here on this horizontal axis, the x-axis, you know, you're supposed to have like, it's the number line. So it goes from negative infinity to positive infinity. Now, let's say you have the following graph of the function f. Let's say this is the graph of my function f. Okay, I have this is my f of x. All right, this is my graph, and the question, of course, is to find the domain. So I need to find the domain as usual. We are interested in the domain. So first thing to remember, guys, is that the domain, that's the set, you know, of all x values that you can input, right? So the domain, it's really about the input x, right? It's about, you don't really care about the output y. So this is really about the input. Oops. So this is really about the input x. Input x, right? So how do we find the domain? Well, I'm going to use actually vertical lines. So first, I'm going to start from the left. So for example, let's say you are here, like -3. Let's say your x is -3, right? What will be the output, the corresponding to x equal to -3? So remember, guys, to find the corresponding output, we are supposed to draw like a vertical line passing through -3, right? So what will be f of -3 in this case, guys? Any guess? What will be f of -3? Well, it's just because, you know, your vertical line passing through -3 doesn't intersect the graph, right? There's no intersection with the graph. So f of -3 is just undefined. There's no answer. There is no corresponding output y, right? So the answer here should be undefined, right? F of -3 is just undefined. It's not, there's no corresponding output y, no corresponding output y. Right? Because, and the reason is, well, there's no intersection with the graph, with the red graph. When I say the graph, it's the red graph, right? Red curve, right, of f of x. So because it, sorry, probably I should, okay. Yeah, so should probably mute. Okay.
Hello, I don't hear anything. Am I
Yeah, did
missing
you
something?
mute yourself?
Sorry. Sorry.
You're currently muted.
Do you hear me?
You have two spots in the meeting, so you're gonna get a feedback.
Oh yes. Sorry. Right, what's going on here? Okay, now do you hear me? Yes.
Yes, it sounds good.
Yes.
Okay, sorry about that. I'm really sorry. It happens sometimes. All right, so yeah, so this f of negative v is undefined, so which means that this x equal to negative v, it's not in the domain. Okay, because there is no corresponding output y. Okay, so x equal to negative v, it's not in the domain. The same thing as you can see here, like for negative 2, there's no intersection with the graph, so no corresponding output y, so there's it's not in the domain, etc. So the first intersection with the graph would be at, as you can see here, at negative 1. So when x is negative 1, you can see we do have an intersection here, right, with the graph. So negative 1, it's in the domain of f of x. So of course you take vertical lines. After that, you still have intersection, right? So this whole interval here, like from negative 1 to, you arrive at positive 1. So at positive 1, we do have intersection at this point right here. So the interval from negative 1 to positive 1 would be in the domain of f of x. But after that, guys, of course, for example, if x is positive 2, there'll be no intersection, etc., etc. So the domain of f of x in this case would be the interval negative 1, positive 1. Now, do we include negative 1? Yes, because, well, at negative 1, we do have an intersection here. And the same for positive 1. We do have an intersection with the graph, right? So in this case, the domain of f of x is, so that will be negative 1, 2, comma, positive 1. Negative 1 and positive 1 both are included. So they are included because, well, we do have an intersection at negative 1 with the graph at negative 1 and positive 1, right? So that will be the domain. So that's the final answer here. So the domain is is equal to negative 1, positive 1, both included. Okay, so the idea, guys, you want to find the domain, you have the graph of a function f, and you want to find the domain, just use vertical lines. And whenever your vertical line intersects the graph, then the corresponding x would be in the domain of f of x. Okay, so the idea, let me just write down here for you. So you use, to find the domain, just use the vertical lines. And so if there's an intersection, then the corresponding x would be in the domain. If there's an intersection, and because there's an intersection, it means that the corresponding output y is well defined, right? If there's an intersection, then corresponding x is in the domain. All right. So that's first example. Let's do another example. Let's do more examples. So next, example number 2. example number 2. Oops. Okay. Okay, so this is my X, input X, output Y, as usual. Again, this is supposed to be my number line, so it goes from negative infinity to positive infinity. And here, let's say this is -1, -2, 0, etc. All right, so let's say the graph of f of x is the following graph. So let's say we have an empty circle here, and then a full circle here, and then a full circle here, and it goes all the way down here. Okay, so just to remind you the notation, guys. So if you have a full circle, that's not, okay, so full circle, it belongs to the graph, so it's included in the graph. If you have like an empty circle, that will be excluded, right? It's not included, it's excluded from the graph, of course. And if you have like an arrow, like this one here, it means that the graph doesn't stop, it goes like all the way down, okay? So the graph is just continuous, it doesn't stop. All right, so let's say this is the graph of my function f, and I want to find the domain, of course. Find the domain. All right, so the idea, of course, is just to use the vertical lines. And whenever vertical line intersect the graph, then that will be the corresponding x would be in the domain, right? So again, I don't really care about the y in the domain. I'm just interested in the input x, right? So you start from the left. Yes.
For this example, is the x supposed to be like that? It says -2 and then it's followed by -1.
No. Well, first, you start. You're supposed to start like from. You go from left to right. Okay, so like in this example, first, well, if you start here from the left, you're supposed to start from the left. There is no intersection, right? And then you arrive at -1. And here at -1, because this is a full empty circle. Sorry, this is an empty circle. So then -1, it's not included. So
yeah, but my question
included.
is,
yeah,
in the number line, it should be like -2.
Sorry about that.
Yeah, that's what I'm talking about.
Sorry, I'm sorry. Sorry, it's my, sorry about that. Thanks. This is -2, of course, and this is -1. Absolutely, you're right. So yeah, actually, so -2, it's not included. So -2, it's not included in the domain, right? So, and then after that, you're gonna have intersection, right? Between -2 and -1, like right here, you're gonna have intersection, right? So then the whole interval between -2 and -1, so this interval here, between -2 and -1, you do have an intersection, right? With if you have a vertical line, you do have intersection with the graph, okay? But then be careful, guys. So between -1 and 0, if you take a vertical line between -1 and 0, there is no intersection, okay? So if there's no intersection, then that's not in the domain. Okay, so then when you arrive at 0, and then you're gonna have intersection again at 0 right here. Okay, and then, you continue, so you still have intersection all the way to positive infinity, right? Because here at positive infinity, your graph goes all the way down. So you're supposed to have intersection like when you arrive very close to positive infinity. So then the domain here in this case, so you can have intersection with the graph like between 0 and positive infinity. All right. So the answer would be, so the domain in this case, so the answer, domain would be, so first, there are, as you can see, there are two different intervals, right? First interval, -2 to -1, and then second interval from 0 to positive infinity, right? There are two different intervals. So first interval, -2, -1. That's my first interval. Now, do we include -2? Is it in the domain? Well, it's not in the domain, again, guys,
No,
because
you
of this
got
intercept.
parentheses.
Yeah, so we got parentheses, absolutely. So this is parentheses here. Now, what about -1? Is it in the domain? Is it included?
Bracket.
Bracket, absolutely. Thank you. All right, that will be my first interval. Union, of course, with the second interval, and the second interval, it's from 0 to positive infinity. And again, guys, just be careful. Between -1 and 0, there's nothing. There's no intersection with the graph, with the red graph, right? So the second interval, it's actually from 0 to positive infinity. 0 is included because there's a full circle here. So we include the 0, that's a bracket, and infinity as usual, it's a parenthesis. Okay. Any question about this example, guys? Yeah, just be careful with the notation, right? This full circle, blah, blah, blah. So you just, you know, just be careful. And again, the idea is just to use vertical lines. Whenever your vertical line intersect, then the corresponding X would be in the input. It would be in the domain, okay? And again, the idea here, guys, is that, so if you take, so what does it mean, my answer? What does it mean the domain to be like -2 and -1, etc.? It means that, so if you take a number which is not in the domain, so for example, if I take f of -5, well, as you can see, -5, it's not in the domain, right? Here, for example, -5. Well, then the answer to f of -5, the corresponding output y, it's just undefined. Because this -5, it's not in the domain, because -5 is, it's not in the domain. So that's what I mean here by the domain, right? Now, if you take a number which is in the domain, so for example, f of +1, right? F of +1, well, +1, it's in the domain because it's in this interval 0, positive infinity, right? +1 would be like somewhere right here. This is +1, right? So it's in the domain. And if it's in the domain, then the corresponding output y would be some number. So it'd be some, I'm not sure what would be the number here, but let's say f of +1, it's, let's say 2, +2, okay? So it would be some number, let's say +2, right? So it's not undefined, it's well defined. So it's well defined. Okay, so that's the difference for a number to be in the domain or not in the domain, right? If it's not in the domain, it means that the corresponding output y, it's undefined. If it's in the domain, then the corresponding output y will be some number. Question, guys? All right, so here's an exercise for you before, how much time do you have? Like 8 minutes, that's good. All right, if there are no questions, guys.
I have a question, Professor.
Yeah, please. Go ahead.
For the first example.
First example, let me just come back to first example. Yes.
Why you didn't choose the -1 and 2? Instead, you chose the 1 and -1. That's what I understand.
Yeah, that's okay. That's a good question because as you can see here, the domain, it's about the set of the values of x, and the values of x, the x, that's the input, right? And the axis of inputs, that's the horizontal axis. right? So I don't really care about the vertical axis because my input X, it's in the horizontal axis, right? So I don't really care about the vertical axis. So the domain is supposed to be the set, you know, of all the values of X that you can input. And the X, that's in the X axis, that's the horizontal axis. So that's why the answer is -1, +1. And I don't really care about this +2 here. It's in the vertical axis. It's the axis of the outputs, right? So again, the domain, it's about the inputs X. And the inputs X that are represented by the horizontal axis. That's why I don't really care about the vertical axis. You see what I'm saying?
No.
No. So again, your question is why I didn't take this +2, right? I just took the -1 and +1, right? That was your question, right?
Yeah.
And so what I'm saying is, for the domain, I only care about the horizontal axis because that's the axis of the inputs. So I don't really care about the vertical axis. So that's why I took the vertical lines, and whenever the vertical line intersect the graph, so I take the value which is in the horizontal axis, the X axis, which is -1 here. I don't really care if the corresponding output is +2. So I took -1 because -1, it's in the X axis, and I took +1 because that's in the X axis. Okay, I'm only interested in the X axis.
Yeah, got it. Thank you.
Mm-hmm. Sure. That's a good question because I mean, for after the domain, we study the range, and the range would be about the values of the output Y. So for the range, we're gonna we're gonna be interested in the vertical axis. That's the axis of the outputs. So you're right. I mean, the next thing to do is actually to study the values on the vertical axis, the axis of the outputs. Oops. Okay. So yeah, we have like 4 minutes. Well, I guess we can do like one graph at least. So exercise for you guys. Nice. Find the domain. All right, so okay, so this is my the graph of f of x. All right, so well, let's say you have 2 minutes, guys, to find the domain, right? You need to find the domain. There's an arrow here. This is an arrow, supposed to be an arrow. Same thing here. This is an arrow. Maybe I should So again, the idea, guys, to find the domain, use vertical lines. Whenever your vertical line intersect the domain, intersect the graph, then the X would be in the domain. So Lewis, you're saying negative infinity, -2. Yes, very good. Yes, very good, Lewis. Excellent. Yes, absolutely. That's it. Oh, sorry.
Zero is
zero. Yeah.
excluded. Yeah, I just noticed that I wasn't colored in.
Just, yeah. Yes, just have to include the zero. Just be careful with zero. All right, sorry about that, guys, but because we have just like 1 minute. Yeah, so for this, I'm gonna do more examples probably next time. And then, as I said, next time we would study the range. So we'll be interested in the vertical axis. But yeah, so for this one, we use vertical lines. So here you start from the left. You always start from the left. And here, and like when you are close to negative infinity, of course, you do have intersection, right? Even if it's not like a full circle, it still belongs to the graph, right? So like here, you have intersection, even it's not a full circle, okay? So you do have intersection, which means that like you like the domain would be like from negative infinity, and then you have to stop at -2 because as you can see at -2 there is no intersection because of this empty circle, right? So and then between -2 and -1 there is no intersection, right? So you have to exclude the values between -2 and -1, and then after at -1 you do have intersection here, right here. So you're gonna have domain would be like from, and then the domain would be like from -1 to, and then 0 excluded, and then again you start at you're gonna have again intersection at +1 right here at this point, and all the way to, of course, positive infinity, right? So with positive infinity here, you do have intersection. So as you can see here on the x-axis.
I'm sorry, excuse me, Professor. I have to leave. I have another class, but we're gonna do more examples like this.
Yeah, next time, sure. I'm just gonna just write down the answer, and you are done
with the broken
today.
graphs, like the way it is here. Like,
yeah, broken graphs.
Okay.
Yeah.
Okay. Thank you.
So,
bye.
Sure. Bye. See you next time. So this is -2 excluded, and then union second interval will be like from -1 included, 0 excluded, union with 1 to positive infinity. +1, of course, is included. All right, sorry, went over time, guys. So yeah, I will see you next time. And next time would be Monday. Okay, so there are no classes on Wednesday and Thursday. See you next time. See you and take care, guys. Thank you for listening.
All right, take care.
Take care. Take care, everyone.